Okay, we're gonna test one more harness. Tony has it connected already. He's gonna select his map. Continuity. Simply we just have some out of tolerance once again, plus or minus 2 ohms. Those will be adjusted. There are no continuity opens on this harness. Shorts is running, pass. Now we are in intermittence mode. Tony's gonna provide environmental stimulus.
There it is.
Do that again, Tone. Let me make sure I'm on the screen.
Ready?
So you can see there.
See the numbers.
Yeah, let me zoom in a bit more. Hold it right here, Tone, so you can see the manipulation and then the events climb, even right out in front. So as he's wiggling that, you can see the events begin to climb. One more time, up a little higher there. On the right hand side, you can see the events, and it just glitched out at 50 events. So on test point 18 and test point 42, we have numerous intermittent hits. On test point 18, it glitched out at 50. We set that limit because we know there is a massive intermittent issue there. On test point 42, there are 38 events, a very heavy intermittent test point. And to point out, obviously these intermittent type issues were not found during continuity. Continuity test is the same type of test that is done by AWITS and all of the other types of conventional testers. So intermittence mode is very different with stimulus, monitoring all circuits simultaneously and continuously according to MilPerf 32516, down to 50 nanoseconds. We pick up all of those issues, those intermittent events that cause no fault found test results. So we've now stopped this. We're done providing the stimulus, and now we move into fault isolation, where Tony will now visually take these to root cause. So we're gonna focus in on the test point 18 with 50 events. We click the readout. And you can see there it's behaving intermittently while we're focused in on one test point. So in a resting state, Tone, it seems like it's getting a reading there, right? So there's some wiggle. Go ahead and wiggle. All right, so we're seeing that intermittent hit. So Tony, we now know on test point 18, right there at that bigger connector to P1, that's where we would focus in on, and the technician would then go in with magnification and repair. So we'll now look at test point 42, more in depth. And you can see that chatter that's occurring while focused in on test point 42. Okay, same thing, 42 would then be repaired accordingly. Now that we've looked at both of these test points that have intermittent issues, we push play. Saved our report out to the desktop once again, just to take a look at it. Those are just out of tolerance, shorts passed, intermittent. Test point 18 shows 50 events, test point 42, 38. Then be repaired, at which point you would come back to verify that the repair has been conducted according to intermittent free guidelines, and then we would rerun the test. And that's the process. So for existing cable sets that may be owned by an organization or a military or a country, we have designed what is called a patch cable. So Tony is going to show this patch cable, J1 through J6. This is a 256 test point patch cable, and we simply connect 6 of those 50-pin D subs to our tester, and then on the other end, these are the mating connectors for your automatic wire test set, your AWITS cable sets. So with the power of AutoMap, what it allows for is the ability to, once connected through these patch cables, leverage your existing cable sets. We'll verify that those are free of continuity shorts as well as intermittents. So they are intermittent free cable sets. And then we will leverage those existing cable sets that are owned to test those UUTs. So we would run 2 AutoMaps, one just for verification that your cable sets are intermittent free and a full suite of tests, and then verification that the actual UUT that those patch into are intermittent free. So the patch cable along with AutoMap allows for a lot of savings, leveraging existing cable sets that exist, and then being able to obviously solve no fault found test results through Universal Synaptics intermittent fault detection, specifically through intermittence mode. Thanks for your time.